Hello everyone, so today we are going to do Leetcode Daily Challenge Combination Sum 4. So let me first show you the question. Let's read out the question, then we'll go ahead that how we are required to do this question. So here's the question. So in this question, we are given with one array, target, and then what we are required to do is we need to return all the possible combinations that sum up to this particular target. That's the thing which we are required to do here. And here the array of distinct integers is being given to us. So in all that scenario, no duplication is there. All the combinations would be unique only, right? So in that context, we would be easily able to get number of all the combinations which sum up to this target. And then here it is written the test cases are generated so that the answer can fit in 32-bit integer. Okay, so in this scenario, it's like that whenever we add up all of them, so it simply fit into 32-bit integer. So here the constraints which are given to us, that is the length of the nums array would be 200. That is, at max 200 elements would be there, and at minimum there would be one element in the nums array, and the elements of nums array would be from 1 to 1000 because they have already mentioned that it will fit 32-bit integer. That's why the summation of these numbers would also be into the 32-bit only. So that's why the constraints are like this. And all the elements are unique. That is already mentioned in the question. And the target is also something in the range of the range of nums array elements is there. Okay. And then the follow-up is that what if negative numbers are allowed in the given array? How does it change the problem? And what limitation we need to add to the question to allow negative numbers? Although this is just follow-up, it might be having one more, like it is combination sum 4, so it might be having combination sum 5. In that it would be having some negative numbers. So there we'll solve that portion. So presently we just need to focus on this one, that how we are required to do this. So let's start that how we are going to do it. Now let us take this first example only and check that how combinations are 1, 1 and then 1, 1, 2. Means each number could be repeated any number of times. That is also the thing, and it could add up to 4. And then again the same scenario is there, that previous number could be again used because there are all the combinations. So that's why. And even again any number of times any number could be repeated. Only thing is that it should be unique combination. Means here even this 1, 3 and 3, 1. This is also one of the unique combination only. And here you can also see this one, 2, 1, 1 and this 2, 1, 1 and 1, 1, 2. These are also one of the possible combinations. And these are also categorized under the unique only. So now let us form according to this. So let me show you through the board. So here we can see that if we take this first example only, how our combinations would be. First, our target is 4, right? So keeping in mind about this target, then we are having 3 choices, 1, 2 and 3, right? So when we take 1, then surely from target we are reducing 1, so now target would be 3. And then when we take 2, then we are reducing from target 2, then surely not new target would be 2. And when we are taking 3, then we will subtract 3 from the target, and thus our new target would be 1. So now these are the new targets which we are required to achieve at this point of time. Now the thing is that when we are going for this, then we are further having 3 choices, that 1, 2 and 3. Now we need to check that when target is 3. So yeah, we'll reduce 1 from this target, so now new target would be 2, and then we'll reduce 2 from the 3, then that new target would be 1, and when we reduce 3 from the 3 it would be 0, right? So at this point we found one combination, which is this one, right? And in this we need to proceed further also. So that's why we'll again for the same process. And after getting this possible answer, we'll simply backtrack to 1 and then 1 will check to other combinations. Basically, this is whole of forming a recursive tree, and in that recursive tree, we are just following a particular path into the whole depth, and then when we found the possible combination, our target is fulfilled, then at that moment we simply backtrack. And this is the whole thing which we are doing in this particular question. So that's why this tree becomes like this. And even the time after checking this tree, we can directly see that the time complexity of this recursive solution would be 3 raised to power n. Basically, at each moment, we are having 3 choices, right? This one, and this one. And total at max, how many levels it could go is n, right? So that's why the time complexity is 3 raised to power n. But the space complexity we can say as order of n also, and even order of 1 also. Why order of n? It would be recursive stack size. That is the thing, we can say it as order of n. But if we ignore this point and if we say that we are not using any external memory, it was the internal memory only of the recursion. So at that moment of point, we are using nothing, and thus its space complexity would be order of n or order of 1. So this was for the recursive, and I'm saying that how recursive is ongoing, but this is the main idea behind this particular question. But now comes the next part, that how we are required to implement this particular in the program, because this is somehow the background knowledge which we are required to have for this recursive solution. But then comes the part that how we are required to use this background knowledge towards coding. So here's the next part, that when we were having that tree, then how that tree was ongoing with. We were checking that combination sum of target, means we were choosing a particular target, and then what next we were doing? We were simply subtracting our present element from the target, right? And this was the thing which we were doing, and then calling that particular function again, so that we could get the answer from that particular sub problem, and then we were simply adding that to our main answer. And this whole process goes till n number of times, basically till the n levels, right? You can simply see this tree that it was going till n, right? And provided one more condition is there, that all targets greater than equal to nums of I. This is the thing which we were doing here. Here we have put the cross at that moment when target became, means here you can see the target became -1, right? So that's why we were discarding this one, and that's why this particular branch was never taken, and it was simply backtracked, and it was mentioned as an invalid case at this particular point. So that's why we are mentioning this particular condition also, that for all targets greater than equal to nums of I. So this was the thing which we are doing for at this question, and this is what we are required to implement in our program. So this was the base knowledge, and now this is the thing which we are required to implement in our program. So for recursion, for implementing into our program, what we are required to do is that we are calculating for given target, right? That was the thing which we were doing at the first step, and then we are reducing it to a newer target and solving for that. So that was the thing, that we are given with the highermost level of target, and then we are subtracting the present element from that target, and then we are solving for that particular subproblem. And this is what we call it as recursive version, that solving our main problem by dividing it into smaller problems. So this is the thing which we are doing here. Now for recursion, means for every recursive question we are required with the base case and recurrence relation for modifying it into a program. So here the base case would be when target equal to 0, then we are required to return 1, and the recurrence relation would be something like this, that we are required to add up every possible combination, means every valid possible combination into a result by calculating for this, means while passing this as the parameter target minus nums of I, and we need to keep in mind that it is valid, and then only we will be adding all that into a result, and thus at the end we will be returning our result. So this is how we would be coding our recursive solution. Now comes the part, because this is a problem as per the constraints, we can solve this question in using DP also, right? So we can memorize this particular question, and for memorizing I'll show you up in the code that how we can memorize. It is pretty much simple. Means after doing it in recursive part we can then memorize it. But now comes the part that how we will be required to do it in the bottom up manner. So for bottom up manner, we would be required for this particular formula. This formula will help us for doing the bottom up manner also, because here the thing was that we were taking the function, and in the bottom up manner the thing would be that we will replace this function with a particular data structure. Means it would be either a array, a vector, or a map. With that we will be replacing this particular function, and we will be storing answer in this particular and then returning the particular integer at the particular point of iterator, we can say. Yeah. So now here is the bottom up variation. So in bottom up version, how we are required to do is, there we are having state and there we are having transition. These are the two main parts of a bottom up approach. So our state would be this, that result of target. This would be our state. That is the thing which we were doing here. Means the combination sum target. This was the function and this was the parameter, and here this would be the array and this would be the index at which we would be storing our particular answer. So this is the state for our DP solution, and now comes the part of transition, that how we would be proceeding with this DP solution. So it would be something like that result plus equals to the same way we were doing in recursion, and here the only thing would be that we will replace our function with the result array, and our parameters there were target minus nums of I, and here it will be acting as the index. So this is the thing which we would be doing. And here for bottom up approach and even the top down version, our time complexity would be simply order of n into t, and the space complexity would be order of t. Now here comes the part that what are n and t. N simply refers to all the numbers which are being given to us in the input, and t simply refers to the target. I will show you that how the time complexity comes to this much, because in most of the cases time complexity is always like number into number or target into target, but here it is number into target. So as per the question and as per the loops which we would be using, you will be able to understand. And here comes the target, because we would be storing at most target number of elements. So that's why the space complexity would be the order of t. And same goes for the top down version of DP also. So this was all for this particular question. Now comes the coding part. So let us show you the coding version of this particular question. So here it is. I've already commented and given out how it would be. So here's the main formula which we are required to use, and we will be calculating for all valid combinations. Now first is the recursive version, that how we are required to do the recursion. So here how the recursion would be ongoing, that this is as the base case, that wherever the remain, that is the target here equals to 0, then we are required to return 1, and the result at the static would be 0 only, and then we will be running a loop for this recursive solution. Why we are running a loop? So that we could get each and every element of our input which is being given to us. Means this is the one, because this is the main function which is being given to us, and from this main function we are going ahead for this particular recursive call. That is the thing which we are doing here, and then we will check, means we will be checking that is it a possible combination or not. So for that point only we have taken this, that if a remain minus num is greater than or equal to 0, then only we will calculate our result, and the result is this only, which I have already explained to you, and that was with this parameter, means calculating for more sub problems, and at the end we will be returning the result. So this was for the recursive solution. Now comes the part that how we are required to memorize this particular recursive solution. So for memorization we would be just using either a vector or a map, and we'll simply store all the answers, means basically we'll store all the combinations which could occur further also. Basically we don't know that which combination will occur again, but if any combination occurs again, then we can simply get that combination from that particular storage, and that's the main purpose of memorization. So in this memorization, that this is the same solution which was above, only new thing is this unordered map. This is for the purpose of memorizing it, and then we are checking that if this unordered map already contains this particular answer, means this target is already present there, right? Then we will return the answer to the same. And then we'll do the same thing which we were doing above, and then we will be inserting again with the remain and the result in this particular unordered map. And this is the same we were doing all above. Now comes the next part, that is our bottom up solution. So for the bottom up solution, what we are taking is simply a result vector whose size we are taking as target plus 1. Why we are adding up this 1 is because of this fact, because at the 0th position we are storing the 1. This plus 1 is basically here for our base case scenario, because at the recursive solution what we were doing was we were simply taking our base case as when target equal to 0, then we will return 1, right? So here when result of 0, that is target equal to 0, then we will be returning the 1. So that's why for further calculations, because this is also one of the sub problem, when target equals to 0, because at some moment of time it will become 0, right? Because we are subtracting each and every number from our target. So that's why this is the base case here. So that's why we are defining the result of 0 as equals to 1. Now comes the next part. Here what we are doing is we are traversing till the target number of times. We are going from 1 till equals to target, and we are checking each number in the nums input vector which is being given to us, and then we are checking that is it a possible combination or not. If it is, then we will simply add up that to our combination, our result, and at the end we are returning the result of target. So this is how we will be doing for our DP solution. Now comes the part about the time complexity and the space complexity. So here you can clearly see that one loop is this one which is running target number of times. That's why it is T. And then one loop is this one which is running num number of times, basically n number of times. So here n number of times simply refers to n are the number of elements being given to us in the input. So that's why the time complexity is T into n, and the space complexity is T. Why it is T? You can clearly see that we are using this particular extra space, right? Because we are required to return just a single integer, but we are taking this particular also for our calculation. So this is our extra space here, and whose length is basically equal to target. So that's why space complexity is T. So this was the reason we are taking this as our we can say space complexity, right? So this was all for this particular question. If you have any doubt, you could comment it down, and yeah, this was all. Thank you.